those that don't know me, I'm Jon Kirby. I guess still working on the A14 to a kind of reduced extent, but me and some colleagues, we've now sort of launched on our own, and we've formed our own company called Ishango. So watch this space. We're trying to do a lot of the, well, I guess the data and reporting side of things that we've learned on A14. And to be honest, it's going reasonably well so far, but we're always on the lookout for kind of anyone in the industry that wants to kind of learn a little bit more or take on some stuff. So if you're interested in something, then give me a shout and connect afterwards. We're also looking into building some apps as well. So yeah, trying to do too much probably, but so what. So anyway, yeah, so kind of cut my teeth on A14 with setting up databases, Power BI and stuff like that. But what I wanted to do for you guys today is just zero in on SQL and databases, and just assume that you're kind of you don't know a thing about databases or anything like that. So we're going to ramp up, and I'll take you through kind of some of the stuff that I've been through. So I guess first question, what is a database? So this will reassure any of those that weren't sure if it was a beginner's class or not. But yeah, database it's a container, it's a bucket, it's somewhere where you store information. I mean, it can be used for all sorts of things, but mainly it's somewhere to store information. Then I'm trying to find the best way of describing the difference between the data that you would store in a database. So the picture on the left here, nice and neat little boxes, things are ordered correctly, and things that aren't ordered correctly. So this is the structured data versus unstructured data. So databases, they perform best when you can set the structure. You can say, okay, we put in a number into this box, we put in a text into this one, and then, I mean, you set it up like that. Whereas a more kind of haphazard approach, which could be a file storage. So if you imagine maybe a OneDrive or maybe a shared drive where you've got folder structures, you've got images, you've got documents, you've got email attachments maybe. So it's a little bit more haphazard, and that's generally the unstructured data approach. You can put this sort of information into a database, but normally you pigeonhole it into one of these nice, neat little, I guess, boxes. So this is kind of still the concept of a database. So generally it's the structured approach on the left and not the one on the right. They come in all sorts of shapes and sizes. This is, I guess, probably the top or the leading database providers. You've probably heard of quite a few of these already. So Microsoft SQL Server, Oracle database, DB2 from IBM. They're the main kind of, what's the word, commercial business-facing databases, whereas other ones such as MySQL, they're more kind of, you build in your WordPress site or something more for kind of end users rather than business systems. But the point with all of these is they are all a version of a structured database. So they're the same, they follow the same kind of principles. You can put information in there in a structured way. They follow the same kind of rules. And then they all use SQL. So SQL is the structured query language. This is, I guess, the cornerstone of all the databases. It's a language, so it's like coding, but it's reasonably simple language. So you can pick it up by the end. What's the time? By the end of this session, you'll have a good idea of what it is, what it does, and how it works. So it's pretty simple to use. Once you get a kind of a feel for the key features of it, then, to be honest, you've made that leap, and you can start to kind of work out more bits and bobs with what you can do with it. So if we imagine that bucket in the middle, the database, how do we put data in it? How do we get data out of it? So these are all done using the SQL language. So you would do an insert or an update to put data in, and then you'd use something called a select to pull data out. Okay, so this is SQL. So the language used to get data into a database and data out. So that's what it is and where it's used. Oops, get me clicker. Right, so what does it look like? So if we start at the top, so in terms of how a SQL query is structured, you can almost read it in English. So you can say, okay, I want to select, and this is star means everything. So select everything from, and then here's the table. And that will return everything from that table. So what I will do now is load up SQL Management Studio. So I'm going to take you through how this all works using Microsoft SQL Server. So this has all been set up actually for a previous hack. So I'm just revisiting old data. But what I want to do is show you these queries, and there may be nuances in the query syntax for other database providers, but on the whole, this sort of stuff is all consistent across all SQL or database providers. So what this is doing here is I'm logging into the Hackathon A14 database. This username and password. Right, so first one to try is this, just select everything from this table. So if I load up Management Studio, so if you haven't seen SQL Server Management Studio before, you'd come in at this level. This is my database level. Sorry, this is my server level. Then here I've got all of these databases, and you can see the icon. That's the database icon. Within a database, you can have any number of tables. So if I just jump into here, when you're using SQL Server Management Studio, to start yourself off, this is a thing that I do quite frequently, is I'll right-click and do select top 1,000 rows. That pings you up a nice new window, and you're already connected up to this database. So it does a lot of that starting setup stuff for you. And what it will do is it will generate a very, very basic SQL statement for you, which is returning everything from this table. So you can see here, if you compare to my example, which was select star from DBO observations, this is actually populating every single field name into this query. But if I just simplify it for now, change that to star. So select star, let's get rid of that just to avoid confusion. Select star from DBO observations, hit that, execute that. And then in SQL Server Management Studio, you can see the returned items in this table at the bottom. So some kind of neat trick which may find useful, depends on if you're analyzing data a lot, but you can actually grab that data and pop it in Excel. Not entirely recommended, but if you're doing some kind of analysis, you can click on the top, Control-C to copy, Control-V to paste. That's quite a big data set, so I'll probably regret that. But that's a quick way of grabbing it if you wanted to just maybe put some filters on, you wanted to evaluate the data quicker. Obviously, this is not connected to the database, so you're just doing things outside of the database just for evaluative purposes. So I'll close that. But that's how easy it is just to kind of grab the data if you're just learning how to work with the data that you're putting in. So the next one, I might just check the chat just to see if anyone's got any questions. Okay. So in order to kind of expand on this, say you want to change the ordering, change the filters a little bit, you can just type, and this is where the natural English stuff comes in. So you can read this now. Select everything from observations, order by, let's choose a column. So let's order by section. As this is typing, as I'm typing, it's auto completing. So if it's highlighted there in blue, I can hit tab and it will complete that for me. And then I can do ascending, which is ASC, or descending, like that. Another shortcut, hitting F5, that will do the execute. And so now we're ordering descending by section. If I change that to ascending, then you should see, yeah, null is the first value. So it's pretty easy to kind of get yourself started in a kind of getting the basics. You just read it basically in English. So select everything from observations, order by section. And then the next one in my list was then where, okay, so you want to do something cool. It's all very well known, the basics, but let's start to play around with this data a bit more. So the example I've got here, we're using a count. And this is some of the things that if you're building up a system, then you'd probably do some of this in Power BI or wherever you're pulling the data into. But you can do it in SQL as well. So let's say, for example, let's follow this practice type. There it is, press tab. I want a count of the number of IDs. Count the number of IDs per practice type. So this is where the natural English bit kind of loses a bit. But what I'm doing here is anything this side of the from will be the columns that are shown, and then everything after it is more about the filters and the sorting and stuff. So I want to show practice type. So hazard, good practice. These are my hazard. These are my I guess categories from observations. And then if I was to just run that, it would give me an error because at the moment I'm not doing any grouping. I'm not grouping by practice type. So it doesn't know what to do with this. If I were to take practice type out and do that, it would work because it's saying, well, okay, you just want to tell me how many rows are in the database, basically, in this table. And it will just go away and count. So we've got 46,000 rows. But as soon as we say, actually, we want to break that down by practice type, practice, oh, there we go. Then I would need to do a group by. And this is another one which is nice natural English. So we want to group by practice type and hit that. So now it's doing this count of ID per practice type, and we've still got those nulls there. So we've got 35 nulls. So if you're evaluating the data that's sitting on your database, then this is one way to kind of, I guess, build up your SQL queries for testing. Okay, so we can keep going into more complex stuff. So you can build up, so this one here, where you've got a filter. And well, how am I on for time? I haven't got a clock. Okay, yes, I'm doing all right. So what we're doing now is we're just building on top of these SQL queries. So we can select everything from this observations table. We can add in the filters. So we can say, okay, I'm only looking at section 3, and you can use and to join together different filters. And incident type equals PPE, and practice type equals hazard. So you can do all of this concatenation of filtering just by putting and in. We can add that into this. So I can say where practice type equals, and then we use a single quote for doing text delimiters, for doing a string, I mean. So it's not a double quote, it's a single quote. And then I can say I want to just look at hazards. And that will do a filter on that result and just return hazards. So that's how that is. I can chain these together, but I'll power on. So next, we've got some stuff around dates. So in my experience, dates cause a few confusions. So, well, certainly if you're coming from an Excel background where there may be regional issues with year, month, day, or day, month, year, or month, day, year. So it's always something that's I've found quite challenging when it comes to making sure that you're pulling data in and out of SQL correctly. So the way I do it, and the way it's I guess the easiest way to remember is biggest first. So year, month, day. So you do the dashes, you can't really go wrong. But the difference here is this is a date type, whereas some of your columns, depending on what the sources are, they might be in a date time format. So what I've done here is just showing the cast, so you can cast a particular column. So if I just show you what this column looks like, so observation date time, let's remove that. Actually, let's order by observation date time descending. So this is a date time field, so you can see how it's built up. So you've got year, month, date, and then hour, minute, second, millisecond. So that's how it's structured. So you can cast that to just show you the date. So you use a field called a function called cast, and you just cast it as date. Send that, and that will clear out the time element of it. But the good thing about that is you can now, perhaps if you wanted to, do a count of ID per date. So if I run that, it's going to fail because I'm not doing any grouping. So when it comes to grouping by, when you've got this date in, you have to do the group by with the date cast as well. And the order by as well. There you go, live demo. There we go. So now you can see we've got, this is the, I guess our main key. We're doing a cast, converting observation date time just to date. So we're removing the time element of it and we're sorting by it, we're grouping by it, and on every item we're doing a count of how many records there are. So you can see now a nice ordered list, ordered by date with the number of, and this is observations per day, but this is a lot of the stuff you may well do in Power BI anyway, but it's good to see that you can do it quite easily within SQL. So I'm not sure what my last one, I think that actually was my last one as well. So that's, I guess, the chaining of a SQL command for just grabbing data out of the database. Pretty simple to do, simple to read until you get into more advanced stuff. So as in, well, actually it isn't in Blue Peter style. I wanted to do this on the fly so you can see how easy it is to create tables and create stuff in SQL. So here we go. Actually, I think I have created incident types, but I'll do it again. So in order to create a new table within this database, you can do it one of two ways. You can use a SQL command, which is create table, and then you list out each of the columns that you want to add into that table. So we've got ID here is going to be our unique key. We're going to make that an int, which is just a whole number. Incident type, so varchar is variable character, so it can be ABCs, it can be numbers. Basically, it's text, anything that you can fit into a text string. And then this, in brackets, is the number of characters it will allow. Null at the end means it will also allow null items in this row, and description is the same. So we're adding text in. With SQL Server Management Studio, there is a nice little WYSIWYG tool. So if I do new table, it will pull up this here, which if you're using SQL Server is a lot quicker way of building up your tables. So if we go ID and then we'll drop this down. So there's loads of different types of field that you can add in. So float being decimal point or any kind of decimal point number. This is a number where you're setting that how many points after the I guess under 0. Character, number of I think they're individual characters, whereas varchar would then be like a text string, and then the bits in brackets afterwards are the number of characters allowed. And then we've got different variations on it. So small int is a really small number. Well, the reason you'd use this is if you spin up a database and you're using int, it may take more memory than it needs, where you actually, you're only going to store under 100 items in this list. Let's keep it a small int so it won't expand the database too much. So let's just do description. You can use max, will just allow you to just keep going. This is the allowing nulls is this bit here. Might do another one. What could go wrong? Date, update date. So another little trick with this to make things easier is if I do that as a date time, hopefully that will find it. Yeah, you can use some of these additional properties at the bottom. So what I would do for ID here is I don't really care too much about it, but I just want it to be unique all the time. I don't want it to be null. So what I can do is use this identity specification bit. So is identity, I mean, it's always defaulted to no, but if I turn that to yes, that will make sure that every time I insert a new row into here, it will automatically increment the number by 1. You can change it to increment by 2, but there's no real reason really. So you normally do just by 1. So it would start at 1 and keep going up and up and up. But I'll show you how that works. Another neat one is if you're doing, okay, I just want to find out for a bit of traceability, when this update was made, you could add a default value in here called get date. And that will do something similar. So when you insert a row into this particular table, it will increment the ID and it will put in the current date time. So you've got a date time stamp of when it happened. And then if I just do one more for good luck, and I'll do, there we go. What I'd also do is if you make your incrementing ID, so this is unique for this particular table, I'd make that a primary key. So the primary key is saying that on this particular table, to make everything unique, there's a different ID on every single row. So that makes this a unique column. And we can use that ID to then link up to other tables if we want to. But given time, I don't think I've got enough time to go through that. But what we'll do is we'll create this table and I'll save that. And we'll call this Hack 6 Live Demo. So there we go. I created a new table and you should see it then appear in this list. Oh, I probably have to refresh. There we are. If I start to run the SQL queries on it straight away, nothing returns because it's empty. It will always do this wiggly line as well, so I think I have to refresh something or other just so that it recognizes it. But it's a valid statement because it's run, and you can see there's no results. So that's how you create a new table. This is how you would do it using pure SQL, just using the SQL language. But there's no need if you can use some kind of WYSIWYG tool to do it. This is an insert statement. So let's say I want to add a row in, and I'm going to speed up a bit if we're going to cover everything. So what I generally do is I try and grab some of the stuff that I've already got. So to build this up, I grab the table name, then I do insert into. This is the table name I'm inserting into. These are my columns. So if I just grab them, put them in a bracket, get rid of some spaces. And if you remember earlier, update date, I don't need to insert in, and ID, I don't need to insert in because they will automatically work. So I'm inserting into that table these fields, and the values are going to be, so description is, does this insert? Okay. And then username, Jon Kirby, close brackets. Another trick with SQL Server Management Studio, if you highlight something in and hit F5 to do an execute, it will only execute what is highlighted. So as you can see there, I've now got one row affected. And then if I quickly just double check, so select star from here, we'll highlight that. There we go. And it's automatically generated my update date. So it's today's date, this time, and then we've incremented the ID. So let's say, can we add another one row affected? And we should see the ID incremented to number 2. So that's basically how you do a quick insert, create table, and then you just double check it now that it's working. So I can do a quick, I'll do a quick update. So let's say, oh, okay, I got something wrong there. I want to change. So let's grab the table name again, update. We're going to update this table with setting username. So let's say I changed my username to Jon Kirby 2. What you can do now is say, well, I don't want to update every single column in this database. Because if I run that, it will update both of them. As you can see, they now say Jon Kirby 2. But let's say where ID equals 1, we actually want that just to stay as Jon Kirby. So that just updates that one column. And now you can see we've got Jon Kirby and Jon Kirby 2. So that's a basic kind of update. You can string these together, you can do wheres. So as soon as you start using a big table, you definitely need to keep an eye on these wheres and make sure you don't blat everything in the database. Oh, and then the dangerous one, deleting. So I can quite happily say delete from that and run that. Deletes everything. So now we're back to having an empty database. So let's put a few in. They're all going to be the same. But now I can say where ID equals 3. And that would just delete that one. So these, I mean, this is kind of, I'm not sure the kind of case for using these, but if you're building up data to go into reports and stuff like that, it's useful to be able to navigate. You're probably less likely to delete or update or insert because you would build that into an app or into Power Apps maybe. So you can then extend SQL into more complex queries. So let's say now you have 2 tables and you've got data in one table and data in another that they link either by a primary key or by some kind of type. And what you can do here is joining 2 tables together. So I've found, I mean, you can Google these Venn diagrams, but these 3 are the main ones. So a left join is where you're looking at a table. So let's say you're looking at the observations table as your primary table A, and then in table B, you'll have maybe a user list or some kind of type mapping. So then you would join the 2 together, but you don't care where there's types that haven't been used. All you care about is the data that's kind of in that primary table. So that's the left join. There is something called a right join. It's basically the same as a left join, but you just switch over your A's and your B's. Full outer join, you just want everything, or inner join is where you only want the data that intersects both of the tables. So the way you build that up is you say, as before, you're saying select, you choose your columns that you want, When you're dealing with more than one table, you have to kind of put in ahead of the column name what table it's coming from. So this is coming from observations ID, observations incident type. And then this example is pulling data from incidents types as well. So then you can put the incident type data in as well. So you do from, and then you from observations, so that's table A, then you left join table B, and then you tell it, how am I linking these two tables together? Any questions?
Yeah, a quick question for me, Katie here. Just wondering, when you're connecting to the data, is it like the whole database you connect to, or just one table?
So normally what you would do is you build it up, so you would connect to the entire database server and then to the database. Normally you would do that. So if I was to connect to this in Power BI, you'd need the first two definitely. So you need to tell it which database server and which database. And then what I was expecting in Power Apps is a little selection so that you can choose which table. So when I load this in, just 2 seconds. When I load this in Power BI, so if I want to do a get data here, and then I'll choose database SQL Server. See, it says here, so it always wants, I mean, you don't have to put the database in, but it always wants the server because that's where it needs to know where to go look. And if I grab this again, so you pretty much need them all in order to zero in on where the data is, because the data will be sitting in the table. So that's where you want to get to eventually. So I would just pop in that and that, and then do that. And then it should pop up a window saying which table. So this is the list of tables there. And there's hack 6. And then when you're in Power BI, you can then load that in.
John, it's Dan Maddox here. I've got a quick question.
Yeah.
Yeah. Because the SQL connection in Power Apps is a premium feature or premium data set, do you think has that limited your opportunity to use it with any particular clients, or are generally they quite open to upgrading licenses to get that benefit?
Yeah, well, it is a conversation, and we've found that when you start having the SQL conversations, you're in a more premium space anyway, because you're dealing with a more business critical environment that requires that level of service. So yeah, I mean, it is a sticking point because there's another charge for getting that premium access. But to be honest, yeah, when you've opened the door on SQL, you've opened the door on that anyway. So it's usually not a big leap.
Right. Well, a big round of applause for John. Thank you, John.
No worries. Thank you.
Good man.
Thank you.
Cheers.